Hello, Math 130 students. We are going to pick up on page 22, which is section 4.7, factoring special products. So here, sometimes when we're factoring, we can see a certain pattern. And for this specific pattern, it's called the perfect square trinomial, meaning that the first term is a perfect square. The last term is a perfect square, and the middle term is twice the first times the last, okay? So for example, it's gonna factor into a plus b squared. So looking at number 1, so if I want to see if it fits into this pattern, let's look at 49. So we're going to be looking at this first term. Is this a perfect square? Yes, it is. The square root would be 7x. And so what we're doing, we are squaring it. Then we have our last term over here. Is that a perfect square term? It is. That would be 2 squared would be 4. So would it be true that I would have 2 times the first times the last? So let's call this the first. Let's call this the last, as in the first term and the last term. So is the middle term 2, so twice, times the first term, and the first term is 7x, and my last term is 2. Well, let's see what that middle term turns into. 2 times 7 is 14. 14 times 2 is 28. So it does fit that pattern. So because it does fit that pattern, then we can say that the way that this is going to factor is going to be the first term minus the last term squared. So that first term we said was 7x minus that last term we said was 2, and we square it. So that ends up becoming my final answer, okay? It is because it worked out in this pattern. If you didn't see that pattern into the AC method, that's fine. This is just an alternative to the AC method or even the guess and check, okay? So let's look at number 2. Let's see if this also falls through the perfect square trinomial. So let's look at our first term. So this is the first that I'm looking at. So can it be written as something squared? Well, it can be. I know that 8 times 8 is 64, and better yet, I have an 8x, okay? Let me write that a little bit nicer in the middle. So we said that was 8x, okay? Now, I'm going to look at that last term. So can I have something squared to be 49? Yeah, that term would be 7. So now, let's again think about this middle term. Is this going to be 2 times the first? So the first one would be 8x. And then our last, we said, was 7. So let's see what that ends up getting us. So we have 2 times 8 times 7, which is 112x. And if they're all positive, then it works out. So this definitely hits that pattern of that perfect square trinomial. So I'm going to have this as the first plus my last squared. So I'm going to have my 8x plus 7 squared. And that's how I know that this is going to factor, because it follows that pattern of that perfect square trinomial. So let's see if these also have this. So I'm looking at number 3, and I'm like, okay, well, what's different about this is that I have 2 variables in that first term. I have that u squared and that v. So it looks like for this one, I'm going to deal with my greatest common factor first. So if I'm looking at my GCF, I have 4, 16, and 16 as the coefficients that I'm looking at. So I know that 4 can go into each of those numbers. Now I'm going to be looking at my variables. So if I'm looking at my variables, let's see, do they all have a u? Well, 16 does not have a u, so it's not part of the GCF. But v is part of all three terms, so v will be part of my GCF. So 4v ends up becoming my greatest common factor. So I need to factor that out first before I see what type of pattern it can follow. So I'm going to have a u squared plus 4uv plus 4v squared. Okay. So then from here, I'm going to see that perfect square trinomial or binomial. So this is definitely my first term. It can be written as my u squared. If I'm looking at that last term, well, I know that square root would be 2 times v. So let's see, would my middle term be 2 times the first times my last? Let's see what that gives me for that middle term. Well, for that middle term, I would get a 4uv, which is what I want. So now I know that this is going to turn into my first plus my last squared. And don't forget that GCF out in front. So I'm going to have a 4v times my u plus my 2v squared. And that ends up becoming my final answer. So now looking at number 4, I'm looking at this and okay, I have 75, 180, and 108. So I'm going to try to see if there is a GCF here. So it looks like we have 3 as our GCF. So the greatest common factor, if I'm looking at all of these coefficients, that's the only thing I'm looking at, so I'm only looking at the coefficients, my GCF would be a 3. So I need to factor out a 3 before I do anything else. So with that being said, 75 divided by 3 is going to give me a 25. So we'll have a 25q squared minus, and my 180 divided by 3 gives me a 60. And 108 divided by 3 gives me 36. So I had factored out my greatest common factor. Now I'm going to go ahead and see if I have my perfect square binomial pattern. So for the first, it looks like it can be written as 5q squared. My last, it looks like that would be my 6 squared. I have a subtraction. So let's see, would it be 2 times the first, which is 5q, times my last, which is a 6. So let's see what that gets me. 2 times 5 is 10, times 6 is 60. So it definitely looks like that 60 I get from that middle term. So now I know that I'm going to have my greatest common factor multiplied by my first minus my last squared. So my greatest common factor here was 3. The first was my 5q minus my last, and my last was a 6. So that is how it's going to factor out. Okay. Now for the next part, we're going to be looking at another pattern, and that pattern is called the difference of two squares. So if I have a squared minus b squared, it's going to factor out into its conjugate pairs. And conjugate pairs are when they're exactly the same. The only difference between them is that you have a plus and you have a minus. So it turns into a plus b and a minus b. And we can see that this is true by using the FOIL method. If we were to multiply a plus b times a minus b, well, you would get, right, our first, which is a times a squared, so that's here. You would get your outer, which is your minus ab, which is here. You would get your inner, which is your positive ab, and you would get your last, which would be your negative b squared. So what ends up happening is you have a negative ab and a positive ab, and since those are opposite signs, they cancel out, and you're left with an a squared minus a b squared. So that's how we always know that this is going to work out, because you start seeing a pattern, right? You start doing this 20 times, 50 times, 100 times, 1,000 times. You're just like, okay, whenever I see this pattern, I know exactly how this is going to work out. It's going to work out by factoring by its conjugate pairs. So let's look at example number 1. I have x squared minus 36. So the way you want to think about it is, are these perfect squares? Well, I can think of this as an x squared, and I can think of my last as 6 times 6. So I know that because these are perfect squares, that it's going to factor into the difference of squares. So I'm going to have my x plus 6 and my x minus my 6. So those are going to be my conjugate pairs. Now for number 2, I have 64. So can that be written as a perfect square? It can if it's 8. And I have minus. Now I want to see if that last term, 81, is that a perfect square? Yeah, that would be a 9 and w. So notice how they fits into that pattern of that difference of squares. So this is going to factor as the conjugate pairs 8 minus 9w and 8 plus 9w. So order matters. If the 8 comes first in the equation, in the expression, then it should come first when you're factoring. Okay. So for number 3, I'm looking at this and I'm like, okay, first of all, it's not a subtraction, so it can't be a difference of squares. Also, I see a 16 and a 64 as my coefficients. So if I'm just looking at the coefficients, I can definitely see that there's going to be a greatest common factor. I know that 4 can definitely go into both of them. And even bigger, 16 can. So 16 is going to be part of my GCF. The other thing that I see are my coefficients, or sorry, my variables. If I'm looking at my variables, it looks like each term also has an x. So 16x is going to be a part of the GCF. So I have a 16x that I'm going to factor out first. So that would give me a z squared plus, and 64 divided by 16 gives me a positive 4. So notice how here we have the addition of squares, and here you have to leave that alone. So that's as far as you can go. It only works if you have the difference, which is the subtraction of squares. If you have the sum of squares, you can't go any further. So sum of squares, you have to stop. Can't go further. Okay. So for number 4, same thing. The first thing I want to look at is a GCF. I'm looking at the coefficients and I see a 3. So I know my greatest common factor is at the very least going to have a 3 in it. The next thing I want to look is I want to look at these variables. I want to see if anything's in common. So do they each have an m in common? No, but they both have an n in common. So 3n would be part of my GCF. So I have to factor that out first. So when I do that, I would get an m squared minus a squared. So it's definitely a difference of squares. So this would be m plus a and m minus a. And don't forget that GCF out in front, which was my 3n. So that's going to be my final answer. Now, the next pattern that we're going to see kind of follows more of a formula, and this is having to do with cubes. So when I say cubes, C-U-B-E-S, cubes, it's because it's degree 3. So we have the sum of cubes and the difference of cubes, okay? So the thing that I like to think about is here is if I start off with addition, it's the same, opposite, always positive. So I like to think of it as soap. So I would have the same, opposite, and then you'd have always positive. So for my subtraction, I have subtraction, which is the same, opposite, always positive. So that way it makes it a little bit easier when I am looking for my signs, okay? All right, so now that we know the pattern and we know our signs, we are going to dig in. So looking at number 1, I have x to the cube plus 64. So we want to see whether or not it would follow this cube formula. So let's see if it would follow. So I have addition. So let's see, for the first thing, that's easy, that's x. X times x times x would be x to the third, not a problem. Now, if I have 64, well, let's see, 4 times 4 times 4 is 64. So 4 to the third power is 64. So it definitely fits my outline, which is that x cubed plus my y cubed. But here, that y, instead of calling it y, we're going to put a 4. So that means I'm going to follow this formula in here. So I have my x plus my y, which in this case would be x plus my 4. So I'm going to have my little parentheses. So I'm going to have my x, and I'm going to have plus my 4. Okay. Now I want to go into this bigger parentheses over here. So for that bigger parentheses, it says it's going to be my first thing squared. So x squared. I have my subtraction now. And I have the first and the last thing. So I have my 4x. And it says it's going to be the last thing squared. So 4 squared. So really, this ends up becoming x plus 4 times x squared minus 4x plus my 16. And that is going to be my final answer there. Okay. So let's see if we can do this again for problem number 2. So I'm looking at this and I'm like, okay, well, does this fit the pattern where I have a subtraction of perfect cubes? So 125. So 125 is going to be 5 times 5 times 5. So that would be 125. And I have my y in there. And what about 1? Well, with 1, 1 times 1 times 1 is still 1. So I definitely have my difference of cubes. So now I'm going to be dealing with this one. So it looks like for my pattern, that small parentheses is going to be the subtraction of what I have inside those parentheses. So, okay. And I know I'm going to have subtraction. So it looks like I have the first thing, which is my 5y, and I have my last thing, which is my 1. So I've taken care of that first parentheses. Now I want to deal with this bigger second parentheses. So it looks like I'm going to have the first thing squared, so 5y squared, plus my x value, which is a 5y, times my last thing, which is my 1, and then plus the last thing squared. So now to simplify this a bit, I'm going to get a 5y minus 1, 5y squared. So 5 times 5 is 25. Y times y is y squared. 5y times 1 is just 5y. And 1 squared is just 1. So that ends up becoming my final answer. Okay. So like I said, that takes care of number 2. So looking at number 3, and I just kind of minimized this a little bit or made it smaller so I can still look at the problems while looking at that formula. And I really just like to look at it as I'm doing it. So I want to see whether or not this follows the same thing. The first thing I want to notice is whether or not these have anything in common. Well, I know that 343, if I do it over to the side, 343, that's going to be 7 times 7 times 7. I know that that's going to be 7 to the third power. But the other thing that I'm noticing is that these both have an m in common. So before I put it into any type of formula, I wanted to take out my GCF. So my GCF is going to be out in front. So I have 343 n to the third power plus 8x to the third power. And that's going to make it a little bit easier to deal with, knowing that I have that GCF out first. Always look for a GCF. So again, I want to see whether or not this follows the pattern where I have a perfect cube. So I already know that 343 is 7, and I have my n. And I know that 8, well, that would be 2 times 2 times 2. So 2 to the third power is 8, and it looks like I have the variable x there as well. So it definitely follows my pattern. So because it follows my pattern, I know that I'm going to be looking at this one because it starts off with an addition. So I'm going to start with my small parentheses. So it looks like I'm going to have my, let me go ahead and erase that. I'm going to have my 7n plus my 2x. And that's what you start off in your small parentheses. Now I'm going to be going to my bigger parentheses over here. So it looks like I'm going to have my 7n squared minus 7x times my 2x, all these positive, and the last term squared, so that 2x squared. So when I do that, the first term, or that first parentheses, doesn't change, 7n plus 2x. And now I have 7n inside parentheses squared. So 7 times 7 is a 49, and I have my n squared. Minus, and I multiplied those two, so 7 times 2 is a 14. Now I have an x squared. Plus, oh, and that's not an x. Inside that 7 was an n, there we go. So it's 14 nx, that's better. And 2x inside parentheses squared, well, 2 times 2 is 4, and x times x is my x squared. There we go. And don't forget that GCF from the very beginning, which was m. So that is going to be my final answer. Okay. And I wrote a little too big, and that's okay. I would rather write too big and see exactly what I'm doing than not write big enough and make a mistake. So I'm just going to slide number 4 a little bit over onto my scratch work. So I'm just going to rewrite what I have. So for number 4, the problem is r plus 6 to the third power plus 27s to the third power. So it looks like this one I am dealing with my addition. So I'm going to be looking at this first one over here. And what the funny thing about this is that it's already kind of into that formula where I have something to the third power plus something else to that third power. So here on the inside, I'm going to have my r plus 6 is going to be what's inside my parentheses. And now if I'm looking at 27, well, to get 27, that would be 3 times 3 times 3. 3 to the third power is 27. And I also have my s. So now I know exactly what's going to go in that small parentheses. So I have the first thing, which is my r plus 6, plus the last thing, which is my 3s. And now my bigger parentheses, I have the first thing squared, so r plus 6 squared, minus, and it's going to be multiply those two things together. And a multiplication doesn't matter in what order, so I'm going to have 3s comes first, and then I'll have an r plus 6 that comes last, plus, always positive, the last thing squared. So 3s squared goes inside my parentheses. So now this is going to become, I'm going to leave it as my r plus 6. Maybe I'll keep it in black so that it's r plus 6 plus my 3s, my r plus 6 squared minus 3s r plus 6 plus, and this is where I can simplify this a little bit more, 3s parentheses squared. So 3 times 3 is 9, s times s is s squared. So that ends up becoming my final answer for number 4. Okay. So that is the end of this section. If you guys have any questions, please make sure to email me, the Math Success Center, or our embedded tutor. Thank you.